Okay, here we are in section 8.3. Again, we're still in chapter 8, so we're still dealing with confidence intervals. We've just moved from proportions into means. So now we should be dealing with quantitative data, which would all have means. We're going to be using our x bar to help us estimate our mu, which is our parameter. So for this question, number 58, weeds among the corn. Velvet leaf is a particular annoying weed in cornfields. It produces lots of seeds, and the seeds wait in the soil for years until conditions are right for sprouting. How many seeds do velvet leaf plants produce? The Fathom histogram below shows accounts from a random sample of 28 plants that came up in a cornfield when no herbicide was used. Explain why it would not be wise to use a t-critical value to construct a confidence interval for the mean number of seeds mu produced by velvet leaf plants. Now it's telling us right here that it would not be wise to use the t-critical value. That means it must fail one of our conditions. Remember, we have 3 conditions. We need to check for an SRS, we need to check our 10% condition, and then we check our large counts condition. And remember, for our means, we're checking large counts / normal condition, because if we're already given normal, then we don't need to worry about the large counts part. Now the SRS condition, it tells us that we had a random sample. So that one's been met, so we don't have to worry about it being that. 10% condition, it tells us we had a random sample of 28 plants. It's fair to assume that there's more than 280 of all possible plants that we could be looking at, so that one would be satisfied too. So both of those being satisfied means that something must be wrong in this large counts condition. Now notice we started with 28 plants. That is less than our 30 that we usually check to be able to use our central limit theorem. So we don't have a large enough value, which means we need to look to check if it seems to be normal. They gave us the printout of what the data looked like from our sample. Notice from that we're getting what appears to be outliers here. Due to the outliers and our small sample, it is not safe to assume that our population was normal or that our sampling distribution will be normal. Therefore, it is not wise to use a t-critical value. Remember, conditions always help us. Without the conditions being met, we can't do the calculations. Thank you.